Welcome back, everyone. Today, we're going to talk about how to expand rational numbers. So, at this point, we probably know how to expand basic rational numbers. We probably know that 1/2 is equal to zero point 0.5. But what about ones that are not that obvious? And let's say we don't have a calculator in order to figure it out. How can we figure out how to expand these rational numbers? Well, first thing to keep in mind here is that when we're expanding rational numbers, one of two things is going to happen. Either we're going to get a terminating decimal or a repeating decimal, right? And that's because every single rational number is going to end in one of those ways. Now, of course, decimals do exist that neither terminate nor repeat, but those cannot be expressed as rational numbers because those are irrational numbers. All rational numbers, when they're put in decimal form, must either terminate or repeat. Now, the way we can figure them out is by remembering that having a fraction sign, right, having a fraction is the same as division, right? This is the same thing as saying 2 divided by 7. This is the same thing as saying 5 divided by 8. And this is the same thing as saying -10 divided by 3. And so, by doing this long division kind of question, we are able to figure out the expansion of all of these rational numbers. Okay, so let's try the first one, 2 divided by 7. Now, something we might be tempted to do, we might be tempted to put 2 here and 7 here. However, that's not quite right? Keep in mind that the numerator is going to go in here, and then whatever we're dividing by, right, our dividend is going to go here, and then our quotient is going to go on the top. And so it's actually going to look like this, 7 into 2. Now, of course, how many times does 7 go into 2? Well, 0 times, because 7 is greater than 2. Even 7 times 1 would give us 7, so the only number we can put up here is a 0. And we would have remainder 2 normally. Now, that said, just saying that it's 0 with a remainder 2 doesn't really help us. What will help us, though, is by saying, well, 2 is the same as 2.00. So let's put a couple zeros on the end. And we're going to keep adding zeros here to the end of this number until we either have a terminating decimal, until this ends at some point, or as far as this repeats, right? If we ever get a repeated digit, we know we can stop there because we will at that point understand the pattern. Okay, so how many times does 7 go into 20? Well, 7 goes into 20 2 times. 7 times 2 is 14, and then we subtract. 20 minus 14 gives us 6, and then we bring down the 0. Okay, how many times does 7 go into 60? Well, 7 times 9 is 63, so that's a bit too big. But I think 7 times 8 will work because that's 56. 7 times 8 is 56, and then we subtract and get 4. Now we still have not gotten a 0 down here or something repeating, so I'm going to add yet another 0 to bring down here. How many times does 7 go into 40? Well, 7 times 5 is 35, and that's probably as close as we can get here. So 7 times 5 is 35. 40 minus 35 is 5. And then we're going to bring down the 0. Okay, how many times does 7 go into 50? Well, 7 times. 7 times 7 is 49. 50 minus 49 is 1. And then we're going to bring down the next 0. How many times does 7 go into 10? Well, 1 time. 7 times 10, or 7 times 1, is 7. 10 minus 7 is 3, and then we're going to bring down another 0. How many times does 7 go into 30? Well, 4 times. 7 times 4 is 28. 30 minus 28 is 2, and then we'll bring down the 0. How many times does 7 go into 20? Well, now that's a familiar question. We asked that in the beginning. The answer was 2 times, right? And then we will get 7 times 2 is 14. 20 minus 14 is 6. And it's just going to repeat this same pattern that we did before. All of this will repeat again and again. And so therefore, the final answer to this question is 0.285714. And all of that is going to have a bar over it because this is going to repeat again and again. As soon as we see this 2 and we recognize that, oh, hey, there was a 2 here. And so therefore, this whole pattern is going to keep repeating again, exactly the same as before. And the reason we know that is because these zeros are going to keep repeating, right? These numbers aren't going to be different numbers other than zeros. It's only going to be zeros added to the end. And so once we start to see a repeating pattern, we know that repeating pattern must continue because the zeros at the end of our long decimal number there must continue. All right, let's try the next one, which is 5 divided by 8. Okay, so for 5 divided by 8, again, we're going to put our 5 here and our 8 here. How many times does 8 go into 5? Well, 8 is larger than 5, so 0. How many times does 8 go into 50? Well, let's see, 6 times. 8 times 6 is 48. 50 minus 48 is 2. And bring down the 0. How many times does 8 go into 20? Well, 2 times. 8 times 2 is 16. And then 20 minus 16 is 4. And we'll bring down another 0. How many times does 8 go into 40? 5 times. 8 times 5 is 40. And 40 minus 40 is 0. So this time something different happened. Rather than getting something that is going to repeat again and again and noticing a pattern, we ended with a remainder of 0 after 3 decimal points. That means this is not a repeating decimal, so the 0.625, the 625 does not repeat here. What happens instead here is that this is a terminating decimal where it's just 0.625 is our answer. And that's it, because we got a remainder of 0 at the end rather than just getting a 6 repeated at the end here, indicating that we would just continue repeating this forever. Okay, the next one we're going to do, and the last one for today, is negative 10 divided by 3. So for this one, we're just going to do regular 10 divided by 3, and then we'll keep in mind that whatever our answer is will need to be the negative version of the answer, because whenever we divide a negative number by a positive number, we always get a negative number in return. So we already know that whatever this expansion is, it's going to start with the negative sign. Okay, how many times does 3 go into 10? Well, 3 times. 3 times 3 is 9. 10 minus 9 is 1. And then we bring down the 0. How many times does 3 go into 10? Well, 3 times again. 3 times 3, still 9. 10 minus 9, still 1. And then we bring down the 0. And this is getting familiar, right? This is just doing a pattern again and again. We're going to get 3 again here, and we're going to get another 3, and so on, right? We're always going to just keep this loop where we always get a 3. And so therefore, the answer for this one is negative 3.3 repeating, because that 3, we're never actually going to get a remainder 0 here. We're always just going to keep repeating the 3s over and over and over again for eternity.